Hello everyone, this is Coach Knight again. Today we're going to talk about vectors and how to turn geometric vectors into algebraic vectors. Basically a geometric vector or any vector is just a quantity possessing both direction and magnitude. Just like the evil villain on Despicable Me, his name was Vector. He committed crimes with direction and magnitude, if you remember. That's all a vector is. So here we have the red arrow is indicating a vector and the blue arrow is indicating a vector, and the direction is the direction they're going in, and most of the time we measure that in degrees. At what angle is the vector traveling, and the magnitude is measured by how long is the vector, like we just measure it. So to make it algebraic, we're going to assign an ordered pair to name it using our algebra skills. So the first thing we're going to do is take our vectors, and note, vectors can be anywhere, but we're going to put them in a coordinate plane. So let me make us a coordinate plane here. All right, and I'll just stick it right in between the two of them. Oops, forgot my little vector sign. All right, let's try that again. Okay, so we have the x-axis and the y-axis, and we got a couple of vectors there. Now understand, we can recreate any of those vectors. We basically just have to know what direction it's going and how far to draw the vector. So if you remember how to do points, that's basically how we're going to name these vectors. So this vector right here, let's see here, I'll use green. So this vector starts at that point and ends at that point. And basically you just figure out how far right or left did it go and how far up or down did it go. So this vector would be going 1, 2, 3 to the right. So that's 3. It's a little skinny. There we go. And then it goes up 1, 2, 3, 4, 5, 6, 7 up, and that's 7. And so that is that vector 3, 7. Now, if they just give you the points, okay, here's how you would do it. So this point right here is 1, 2, 3, 4, 5, 6. It's -6, 0. And now notice how I'm drawing vectors. You always know it's a vector if they're using like the greater than and the less than sign to enclose them, okay? If you're using parentheses, it's a point, just like always. So this point up here is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So it's -3, 7. And basically, to get this, you subtract those two. Now, you always subtract from your destination, you subtract it from your starting point. So our starting point was down here at -6, 0, and we ended up at -3, 7. So to get that, we subtract, this is x1 and y1, those are our first point. This is x2 and y2 up here. And so to get this, we are going to say x2 minus x1 and y2 minus y1. And basically, you just do subtraction. So this would be x2 is -3 minus x1 is 3, or excuse me, x1 is -6, y2 is 7 minus 0. And when you simplify that, you get -3 plus 6 is 3. 7 minus 0 is 7. And we get the same thing we got right there when we just counted. So if you have a graph you don't have to worry about doing the little formula there. If you don't have a graph, you can use the formula. Now that formula should look familiar. It's part of your distance formula. So if you don't remember your distance formula, it's the square root of x2 minus x1 squared plus y2 minus y1 squared. And so basically your vector is in here. It's this part inside those parentheses. That's your vector. Okay? So basically all we're doing is changing to get the magnitude. We're changing that d, that distance. Well, that is our magnitude. So basically you take your vector, which we've got was 3. We already did the inside. And 7. And we add them up and take the square root. So 9 plus 49 is the square root of 58. And so 58, I don't think can be reduced, so you can just leave it as square root of 58. So that would be your magnitude. So 3, 7 is my vector, and my magnitude is square root of 58. Now understand, there can be multiple 3 7s. Okay, so let's say I wanted to start my vector here. Well, I would just go right 1, 2, 3 and up 1, 2, 3, 4, 5, 6, 7 and draw my vector there. And those two vectors are equal. They have the same direction, they have the same magnitude. Okay? What about our other one? How about the blue one right here? So the blue one, it starts here and ends here. Well, this point at the top is 1, 2, 3, 1, 2, 3, 4, 5, 6. It's 3, 6. And this point, where it ends up, is 1, 2, 3, 4, 5, 1. And so, like I said earlier, you can just count if you have the graph. If you don't have the graph, you're going to use the formula. So I'm going to do both. I'm going to use the formula first. So that would be, let's see here, this is x1 and y1. The first point is where you start. x2 and y2 is where you end up. So that's going to be 5 minus 3, comma, 1 minus 6. And so the vector for this is 2, negative 5. That's the vector, that's the ordered pair form of the vector. And again, notice, very important, do not put parentheses, because you put parentheses, you're talking about a point. Okay? You can have an infinite number of vectors that are 2, negative 5. There is only one point that is 2, negative 5, though. Okay? So just the quick way, when it's graph, we went right, we went right 1, 2, and we went down 1, 2, 3, 4, and 5. Notice that's my vector, 2, negative 5. Okay, if we wanted to get the magnitude of this one, we take our vector, 2 squared plus negative 5 squared. That is the square root of 4 plus 25, square root of 29. Very, very simple. Okay, so basically your magnitude is just the distance formula. You have to make sure, though, you do the second point minus the first point. Okay, if you don't, you're going to mess up. Okay, your magnitude will be correct, but your vector will be incorrect. All right, now there's also a form, sometimes they ask you to write it in unit vector form. Okay, so the sum of unit vectors is what they're going to ask. Now, when they say sum, that means adding. And basically, what you need to know is what is a unit vector. Okay, so a unit vector, real quick, if you notice all these little arrows I wrote, okay, notice each arrow, the magnitude was 1. Okay, so if it has a magnitude of 1, it is a unit vector. And we say all the unit vectors that go in the x direction, that is I. So vector I is equal to 1, 0. And all that means is we're going to go right 1 and nowhere up. okay? We're going to go 0 up. So all of these, that would be right here. This would be I, vector I, vector I, vector I, okay? Vector j is for the y value, and its vector is 0, 1. So all of these going up were vector j's. Okay? So each vector, again, it's a unit vector, which means the magnitude is just 1, and it is in the horizontal direction, it's called I. If it's in the vertical direction, it's called j, and it's always just one vector. So if they wanted us to write, say, this vector 3, 7, if we wanted to write that as the sum of unit vectors, we would say 3 times vector I plus 7 times vector j. And that's all there is to it. And all that's saying is, hey, I'm going to go 3 in the x direction and then up 7 in the y direction. But they don't use x and y, they use I and j. Okay, if I wanted to do it for my 2, negative 5, that would be 2i minus 5j. And don't forget your vector signs, because that tells you it's a vector. Okay, so let's work some examples real quick. This first example says write the ordered pair that represents the vector from x, negative 3, 5 and y, 4, negative 2. Then find the magnitude of the vector. Okay, so we're going from x to y. So we are, understand what we're finding. We are finding vector x, y. Well, that means x is my first point, y is my second point. So I do x2 minus x1, y2 minus y1, which will be 4 minus negative 3, 2 minus 5. So vector xy can be written as, that would be 7, negative 3. So that means we're going to the right 7, down 3 for that vector. For the magnitude of it, and the way you label the magnitude is you just put vector xy in absolute value. That's how they symbolize magnitude. And you're going to take the square root of your vector. 7 squared plus negative 3 squared. That's 49 plus 9, which is the square root of 58. And that cannot be reduced. So there's your ordered pair, 7, negative 3. Your magnitude is square root of 58. Okay? You may have examples or problems like this. So this problem, they've given us the vectors. We have 3 of them, vector m, vector n, and vector p. They're already in ordered pair vector form, and basically we just have to do the math. We have to do plug in and add them up or subtract them or multiply or whatever, and it's just like you would think it is. So vector m, I'm going to replace vector m with what vector m is. So vector m is 5, negative 7, plus vector p is negative 1 and 3. And basically, you just add them up. You add up the parts that are the same. So 5 plus negative 1 is 4. Negative 7 plus 3 is negative 4. And there is what vector m plus vector p is equal to. If you added those up, the resultant or the result would be 4, negative 4. For part B, subtracting, same thing. We have m, which is 5, negative 7, minus n, which is 0, 4. So 5 minus 0 is 5. Negative 7 minus 4 is negative 11. All there is to it. Just subtract the parts that are the same. You subtract the x's from the x's and the y's from the y's. Part C, 7 times vector p. Well, vector p is -1, 3. So you just multiply that. 7 times -1 is -7. 7 times 3 is 21. Just like doing the distributive property. Oops. My pen is frozen at the moment. Let's see if it won't do nothing. Did it go dead? I bet my pen went dead. So, yep, my pen went dead. Of course it did. Alright, so while I'm letting that charge for a second, we'll go down here to D. D is the longest of the 4 problems. Basically, we're going to take 2 times vector m, which was 5, -7, plus 3, vector n was 0, 4, minus vector p, which was -1, 3. Just plug in the parts and simplify. So you're going to distribute. That will be 10, -14, plus distribute 0, 12, and distribute 1, -3. And then you just add up the parts that are left. 10 plus 0 plus 1 is 11. 10 plus 0 plus 1. -14 plus 12 plus -3. Let's see, that'd be -2, that'd be -5. So, that's how you do the addition and subtracting and multiplication of your vectors. Last couple problems. It says find the magnitude of each vector, then write the vector as the sum of unit vectors. So, these are vectors in ordered pairs. They want us to first find the magnitude, and second, write them as a sum of unit vectors. So, to find the magnitude, we're going to do like we have been doing. We're going to take magnitude is going to be the square root. Since they're already vectors, you just do 2 squared plus 3 squared. That's 4 plus 9. So my magnitude is the square root of 13, which does not reduce. So we're done there. And then to write the vectors as the sum of unit vectors, well, that's the part that we had talked about earlier. You just take your vector, 2, 3, and you add the unit vectors with it. So that's going to be 2 times vector I plus 3 times vector j. Piece of cake. Okay, last one. Our magnitude be the square root of -4 squared plus 2 squared. Well, that's the square root of 16 plus 4, which is equal to the square root of 20. 20 you can actually simplify. If you did your little factor pyramid, that'd be 2 and 10 and 2 and 5. And so since you have a pair of 2's, you can bring that out, and your magnitude will be 2 square root of 5. And then to do the unit vectors, you're just going to take your vector, -4 times vector I plus 2 times vector j. Alright, hope this video about vectors helped. Y'all have a great day, and as always, stay above the line.